All right, problem 6-136. Last problem of the section. Find the inverse of each of the following functions here listed below. All right, and make sure we write our answers in function notation there. So let's start out. We have p of x equals 3 times the quantity of x to the third plus 6. Many of you probably are comfortable now with just changing that to a y. And then once we have that, remember flip-flopping our x's and our y's. So we actually are going to look at x equals 3 times y to the third plus 6. So, and then we're going to solve it. So in order to solve this for y, we're going to have to get rid of the 3 on each side. So let's divide each side by 3. So we're looking at right now x divided by 3 is going to equal, and actually let's separate that. We have y to the third plus 6. Now let's just go ahead and subtract our 6 from each side. And we have x thirds minus 6 is equal to y to the third. And in order to get rid of the third power here, we're going to have to take the cube root. So let's just show that what we're doing there, we're taking the cube root of this side, and we're going to take the cube root of this side. So in the end, we should get the cube root of x over 3 minus 6 equals our y. Now remember, they want us to put it in function notation here. So we're going to have to change this y back. So I'm going to write the answer right up here, and we're going to end up with p. And remember, it looks like it's raised to the negative first power, but it just means the inverse of function p there of x is going to equal the cube root of x divided by 3 minus 6. So that should be our answer for letter A right there. Let's look at letter B now. Letter B, we're going to be dealing with k of x equals 3x to the third plus 6. So again, this is like saying y equals 3 times x to the third plus 6. Let's flip-flop our x and y. So we have x equals 3y to the third plus 6. Let's subtract it from each side. So x minus 6 equals 3y to the third. And we're just going to undo each step like you normally do. So x minus 6 over 3 is equal to y cubed. Again, the y by itself, you're going to have to do the inverse, so take the cube root. And what we're going to end up with there is the cube root of x minus 6 all over 3 equals our y. And then we're going to go back and put it back into our function notation up here. So we've got the inverse of function k. So it looks like k to the negative first power, even though that's not what that means, of x equals the cube root of x minus 6 over 3. So there's 2 of the problems down. Let's continue on with C and D. I'm going to move down just a little bit here. So h of x, first things first, we've got y equals x plus 1 over x minus 1. And now we need to flip-flop our x's and y's. So we're really dealing with now x equals y plus 1 over y minus 1. Now this one gets a little trickier because now we have two different expressions that have y's in them. So we're going to have to get our y minus 1 out of the denominator. In order to do that, let's take it and let's multiply each side by a y minus 1. We now have y minus 1. Oops, let's undo that. Let's make it green so it matches. So we've got y minus 1 times x equals y plus 1. And here's where we come into this dilemma. We still have two different y's here, but we have to get this y out of the grouping symbols. So you're going to go ahead and you want to distribute your x through. So you're going to have xy minus x equals our y plus 1. And in order to end up, solving it for y, we've got to now move this expression back over with the other y here. At the same time, we can actually just go ahead and subtract our 1 from each side. So we're going to do this all in the same step. I'm just getting rid of 1 on each side, so I'm going to subtract 1. And then I'm also going to move the xy term over to the other side, so I'm going to subtract it. So after doing all of that, what you're looking at right now is negative x minus 1 equals y minus xy. And here is where the big trick comes in, or the hardest part for some people until they understand it and realize what they can do. We have two y's and we can't really combine them the way they are, but we can look at this as a binomial and say, hey, what does our two terms here have in common? Well, they got a y in common and a y in common. So we can factor out our GCF. So we're going to factor out y, and we're left with 1 minus x here equals negative x minus 1. So we factored out y as a GCF. And then we're going to just divide each side by 1 minus x. And in the end, we're looking at negative x minus 1 over 1 minus x equals y. To write it in function notation, we'll take it and do that as we go back up to the top. We're going to have negative x minus 1 over 1 minus x. So we've got here the inverse of function h of x is going to end up being, we said negative 1 minus x. I'm sorry, I forgot it, so I have to look. Oops, negative x minus 1, either way would work, over our denominator, which was 1 minus x. So there is our inverse function for function h. And last but certainly not least, let's look at function j. Move it down so we have a little bit more room here. Again, y equals 2 over 3 minus x. Let's flip-flop x and y, so x equals 2 over 3 minus y. Now we still have to get our variable out of the denominator, so let's multiply each side by 3 minus y. So 3 minus y times x equals 2. We can then look to divide each side by x. Now, if you distribute it through here, you're going to have a y and an x attached. Since y is already by itself, we're just going to get rid of what's not attached to it out here. So if we divide each side by an x, we're now looking at 3 minus y is equal to 2 divided by x. We can subtract 3, or you can add y each side and then subtract the 2 over x. It's up to you. Either way, you should end up with y is equal to 3 minus 2 over x. Now, remember, we got a function notation, so the inverse of j is going to equal 3 minus 2 over x. So j, the inverse of j of x equals, one last time, 3 minus 2 over x. And that is your final answer. So, if you have questions, you need to make sure you ask your teacher or go visit somebody and get some math help. This is problem 6-136. Hopefully this helps you if you had questions. If not, so sorry. Thanks for watching.